Hi and welcome to this segment of Maths exam questions on trigonometry. Question 12. The diagram shows a right-angled triangle. Calculate the value of x. From basic trigonometry, we should be able to tell that sine 35 degrees is equal to x over 12. By rearranging the equation, we can find x being 12 multiplied by sine of 35 degrees. Question 13. The diagram shows a right-angled triangle. Calculate the value of x. Knowing that cos x is equal to 6.2 divided by 23, we can derive x from here. Question 24. A vertical flagpole BD stands on horizontal ground and is held by two ropes AD and CD, AD being 15 meters and BC 10.7 meters, and an angle DAB which is equivalent to 38 degrees. Using trigonometry, calculate BD. Knowing that sine 38 degrees is BD over 15, we should be able to identify BD as being 9.235. Next, calculate CD. CD in turn can be derived from the Pythagoras formula as 14.1. Question 24. ABCDEFGH is a cuboid, with AB being 18 cm, BC being 7 cm, and CG being 12 cm. Calculate the angle that the diagonal AG makes with the base ABCD. The solution to this problem is best represented by the blue triangle in the cuboid. Here you start by identifying AC using the Pythagoras theorem against the components 7 cm and 18 cm respectively. You can then go on to identify theta, knowing that tangent theta is 12 over AC. Question 21. The diagram shows a pyramid with a square base ABCD of side length 8 cm. The diagonals of the square AC and BD intersect at M. V is vertically above M and VM is 10 cm. Calculate the angle between VA and the base. The required angle is best represented by theta within the superimposed blue triangle on the diagram. We start by identifying its value of x using the Pythagoras formula. Subsequent to this, we know that tangent theta is equal to 10 over the value of x. With this, we're able to identify the required angle. Question 4e. From the given diagram, calculate PR. PR can be determined using the Pythagoras formula. Incidentally, this is a multiple of 7 of the 3, 4, 5 Pythagoras combination. Question 3. The diagram shows a field ABCDE. Calculate the parameter of the field ABCDE. By identifying ED and DC using the Pythagoras formula, the parameter is the sum of its 5 sides. Next, calculate angle ABD. Apply the law of cosine to obtain the angle ABD. Next question, calculate angle CBD. Apply basic trigonometry for right-angle triangle to identify angle CBD. Next question, the point C is due north of the point B. Find the bearing of D from B. This would be the angles 360 degrees minus angle CBD. Next question, calculate the area of the field ABCDE. This total area is the sum of the areas for x, y, and z. Question 8a. The diagram shows two triangles ABD and BCD, AD being 16.5 cm and BD 12.4 cm. Angle ADB is 64 degrees, angle BDC is 53 degrees, and angle DBC is 95 degrees. Find AB. For the question, you would apply the law of cosines to get to AB. Next, find BC. For this second part, you will apply the law of sines to get to BC. Question 9a. In the diagram, BC is a vertical wall standing on horizontal ground AB. D is the point on AB, where AD is 58 meters. The angle of elevation of C from A is 26 degrees. The angle of elevation of C from D is 72 degrees. Show that AC is 76.7 meters, correct to one decimal place. You can show this by using the law of sines. Next, calculate BD. One method in arriving at the answer is to equate AB being equal to 76.7 times cos of 26 degrees. Knowing that BD is equal to AB minus AD, BD is 10.9. Question 9b, triangle EFG has an area of 70 meters square. EF in ratio to FG is 1 to 2, and angle EFG is 40 degrees. Calculate EF. In this case, I'm choosing to draw the triangle to better visualize what is said. From the laws for the area of triangles, half times 2x times x times sine 40 would be equal to 70. Then we solve for x. Next, a different triangle PQR has an area of 70 meters squared. PQ to QR is also 1 to 2, and PQ is equal to EF. Find the angle of PQR. Do note that the word different is in bold. We shall start by equating theta to the required angle of PQR. With all other parameters needing to be exactly the same, this means that sine theta would need to be the same as sine 40 degrees. This angle is at 140 degrees. That's all for this segment. Do get into our other videos under KT Tutorial channel if you've liked this.